Hi. Welcome to Chemistry Lecture. Today we will learn Chapter 3, Periodic Table. For this part, we will focus on Subtopic 3.1, Classification of Elements. At the end of the class, students should be able to describe period, group and block, and deduce the position of elements in the periodic table from its electronic configuration. Valence electron configuration and chemical periodicity. Element with similar valence electrons correlate with similar chemical behavior. Before we go further, we need to know the categories of electrons first. Inner electrons. Electrons in the previous noble gas, and any completed transition series. Outer electrons. Electrons in the highest energy level. Valence electrons. For block S and P. Outer electron equal to valence electron. But for transition elements, outer electron is not valence electron. As we know, the maximum number of electron can occupied for first energy level is 2 electrons. Second energy level is 8 electrons, while third and fourth energy level are 18 and 32 electrons respectively. For example, chlorine with proton number 17. From the electronic configuration, we can conclude that the number of inner electrons is 10. Or 1 to A to B. Element in the same group, have same number of valence electron. Now, we go more detail about groups. In groups, elements are arranged vertically down the periodic table. The groups are labeled as group 1 to group 18, or 1 to A to B. Every element in the same group have same valence electron. There are some important members in periodic table, such as for group 1, known as alkaline metal, except for hydrogen. Group 2, alkaline earth metal. Group 3 to 12, transition element. Group 16, chalcogens. Group 17, halogen. And Group 18, noble gas. Elements in the same group have same valence electronic configuration. For Group 1, Ns1. Group 2, Ns2. Group 3 to 12, N-1, D1, Ns2. To N-1, D10, Ns2. Group 13 to 17, Ns2, Np1. To Ns2, Np5. And Group 18, Ns2, Np6. For example, when going down for Group 1, we can see the similarity in these configurations of the alkali metals is the number of valence electrons, or valence electronic configuration. Let's go more detail about period. In the periodic table, elements are arranged horizontally across the periodic table. The period is labeled as 1 to 7. Elements in the same period have the same number of valence shell. For example, sodium and chlorine are in period 3 because their principal quantum number of the valence electron shell is 3. All about blocks. Elements can be classified into 4 main blocks according to their valence electron configuration. These main blocks are Block S, Block P, Block D and Block F. Classification of elements, metals, non-metals, metalloids. Metals are located in the left and lower 3/4 of the periodic table. Non-metals are located in the upper right quarter of the table. While metalloids are located in the region between the other two classes, and have properties between them as well. How to deduce the position of elements in the periodic table from its electronic configuration. We only need to identify the valence electronic configuration first, before we deduce the position. Here is summary for deducing the position of an element from its electronic configuration. These are some example. Deducing the position of an element from its electronic configuration. As a conclusion, the periodic table is a tabular display of the chemical elements, which are arranged by increasing atomic number. The columns, called groups, contain elements with similar chemical behaviors. The 7 rows of the table, called periods, generally have metals on the left and non-metals on the right. Periodic table also displayed 4 simple rectangular blocks based on orbital, where the valence electrons are filled.